The Empirical Energy Podcast blows open the silent revolution, rewriting the rules of global energy markets. Measured, verified energy is no longer an alternative. It's becoming the gold standard. We dive deep with the producers, traders, consultants, and renegades driving this seismic shift. Step inside the raw mechanics of how verification and blockchain-fueled trading are dismantling the old systems and creating a future where alternative energy doesn't just compete, it takes over. This is the movement of reshaping energy as we know it, bold, unstoppable, and just getting started. Here is your host, Mark Smith.
Hey everybody, this is Mark Smith, the host of the Empirical Energy Podcast, where we look at the intersection between energy, AI, and blockchain. I'm here with Hans Rempel from Diode. Welcome, Hans.
Hey, Mark. How's it going?
Tell me more about what Diode does and the inspiration for Diode, the company.
Yeah, for sure. My background is I'm an electrical engineer and began experimenting 20 or so years ago with kind of Internet of Things connectivity. Created one of the leading platforms in the Internet of Things called Exosite back in 2009. And the Internet of Things really is about having a sensor or a device or an asset that is sending data somewhere, and then humans or other automated processes can make sense of that and do something with it. But often you'll need to not only get data from an asset, but you'll also need to actually manage the system of the asset. And typically when you need to reach back into the asset, you're using a technology like VPN or something like that allows you to securely connect back into a facility or to a piece of equipment. And so while the Internet of Things is mostly from the sensor or the asset out to a server, and that was Exosite, I started Diode while at Exosite in order to facilitate very secure communications that initiated from a person or from an autonomous agent and allowed that person or agent to be able to, or other devices to be able to reach back into a piece of equipment or a facility to configure those things. And so those are two different things, and Diode is focused really on enabling that inbound secure communication.
Why don't you walk us through a little bit of how Diode works and how it's different than the typical like VPN solution and things like that?
Yeah, for sure. Yeah, so the traditional way to enable remote connectivity to a facility or an asset is to enable a VPN connection to that. Both sides will typically have some sort of keys that enables them to establish a connection. And then the IT network engineering task really is to enable each of those sides to see each other, right? So they can actually establish a tunnel and begin connecting. And so that's the traditional state of VPN that's been there for 30 or so years. The problem with traditional VPN that pretty much everybody in the industry knows about today is, number one, you have to open ports in a firewall to enable those connections to be established. And number two, you have to tell all of the parties involved who is allowed connecting to them, right? And so you have to then configure, it's a multiple system configuration required to manage traditional VPN. And so there's this capability called zero trust networking that was introduced. And zero trust networking introduces this idea of a bridging server. And the bridging server sits somewhere that is publicly accessible so that each side can connect into the bridging server, and the bridging server can just securely connect those things. And so that solves the problem of establishing the connection. And then because the bridging server can be given the access control list, who can access who, it also simplifies the problem of provisioning access between the different systems. However, this is at the cost of security and introducing new vendors into your ecosystem. Right now, you have to trust the bridging server itself. You have to trust that the server is secure. You have to trust that there's nothing wrong with your access control lists. And so what Diode does is we take a zero trust network and we use blockchain to remove the possibility of man-in-the-middle attacks and remove possibility for the vendor itself to sometimes even have access, and for sure to modify any of the access control lists. Because we put these things in blockchain, we then enable the people who are actually responsible for the network, whether it's the customer or the vendor, et cetera, to actually fully control that network definition. And so we call it permissionless secure communications. And there's other aspects of this as well. But in the blockchain space, in the blockchain world, we have this saying that is not your keys, not your coins, right? And this is, if you think about using blockchain or maybe like cryptocurrency, you have to have a wallet that proves that you have access or that those coins are your coins, right? And that wallet can be either a wallet hosted by some website, which is very convenient. You just log into the website and hey, there's your coins. But the problem is if you've given a website access to your keys, really, if that website gets hacked, and this is where most of the hacks in blockchain come in, is hacks against these centralized websites that have keys to everybody's coins, all of a sudden those coins can disappear. And so they have not your keys, not your coins. We've taken this idea of a SaaS system, a software as a service system, something that lives as a software service, but then made sure that the mathematical proofs and the custody of the keys that define whose data is whose and who controls those access control lists are self-custody, that the companies who are responsible for the network actually hold all of the capabilities to change those things. And so the Diode network is a provably secure tunneling network, thanks to full blockchain automation and blockchain anchored network definitions. And so we believe that this is really the future of secure communications for zero trust connectivity.
So I asked Hans, okay, so let's bring it down to something I can relate to. And I actually sent him an image that I used in PowerPoint presentation. I've used it publicly numerous times, but a simplified high-level view of our architecture for Clean Connect and Prove Zero. So I asked Hans, say, okay, show me the way we do it today, and I'll walk through this, and then show me how it could change with diodes. So yeah, this is a diagram that I do all the time, and I'll say, number one, we have our OGI cameras. They connect to an intelligent edge device at the client site, and then we can either connect to SCADA, their SCADA system, through MQTT or Modbus, and then they go up to the SCADA system you see there in the cloud. Then we get a feed, usually could even be off of the AWS SFTP server. Maybe every 10 minutes we're getting SCADA data, and we're integrating it there with Promax on our platform. But yeah, and then we're processing a lot of those using computer vision, a lot of the models, the raw visual data there on the edge, and then we're sending the exceptions like the alerts and things up to the Clean Connect platform there in number 5, and then alerts are shown on a dashboard and so on and so forth. So that's the way we do today, and all the things that you said before at a simplified level, using VPNs, opening up ports to the client's deal, all those things you said are the way we do it today. And there may be exceptions to that. I know that you were talking to one of our chief architect about another product like Tailscale or something like that. But anyway, so show me how this would be done differently using Diode, and maybe even contrast it with a tool like Tailscale.
For sure. Yeah. Yeah. So typically the pieces, and there's not really color coding on this diagram about which pieces are, let's say, within the customer's control, right? Like an oil and gas facility. Sometimes the oil and gas facility is just within the perimeter of that physical facility. Sometimes it's within the perimeter of that physical facility, plus a server running somewhere, maybe a private cloud server running in Azure or AWS or something like that. So really everything here in the fuchsia is the facility, and then the client SCADA up here may be within the facility, may be in a private cloud, etc. But that is also part of the client's infrastructure and things that their internal, developer operations and IT and compliance team have direct access and oversight over. Okay, but almost every facility, every operation has third parties, right? It has suppliers, it has vendors, and such as Clean Connect, and they rely on those suppliers and vendors to sometimes supply an asset like the Clean Connect Intelligent Edge AI machine model device, a UFO device, and sometimes also to maintain those systems. Okay, so it's both communications from the devices as a normal part of the business, as well as sometimes diagnostics and debug and maintenance of those systems. And so really the challenge comes in between the client's assets and the vendor's assets, the supplier's assets. And when you begin opening up ports to multiple suppliers and you need to maintain those over time, there's many facility managers and people responsible for IT security that I talk to that basically feel it's almost out of control, right? That they have so many suppliers and vendors with different ports. They don't even really know what the ports are there for. Sometimes it's not even being used anymore, but yet the port's still open. And it can become a kind of a pretty complex network engineering effort. And so what Diode does is we want to simplify that connection between assets that are directly managed within a customer's facility, a customer's assets, to whatever supplier or vendor is supplying capabilities or needs access to the facility. And so that's diagrammed here in these orange diode lines. And again, traditional VPN, you can do this, multiple ports, multiple provisioning steps. And so many people are using now zero trust networks and bridging networks like Tailscale or Zero Tier, Zscaler, or Palo Alto networks. There's a number of them, probably about 100 different types of networks out there that you could choose from to use it, to be able to secure this connection. But unless I think there's a vendor called Netscope, and Netscope, I believe, offers a bridging network that you can host yourself. And so it gives you the ability to centrally manage who can access what, but at the expense of you are running the entire thing yourself. Uptime, and anything that goes wrong with the servers, etc. But that is the most secure, right? Because you can operate as part of your compliance regime. And so between that, the full self-management, and between something that is fully software as a service like Tailscale, Diode has a middle path that gives you the best of both worlds. And let me explain a little bit how that works. And any questions, Mark, before?
No. Yeah. Explain how that works and how it's different.
Yeah. Okay, cool. Yeah, so some advantages here. The first two advantages that we list are really advantages that are common to these newer breed of bridging networks. Okay, in that in a typical secure connection, say if me as a consumer is going to a bank website, I get the little green browser bar and I say, great, my connection to my bank website, it's legitimate, it's the bank website, and it's secure. Okay, but the problem is that security in your browser is delivered by internet third parties, okay, delivered by DNS servers that tell you where wellsfargo.com lives, and delivered by a certificate authority that says that when you do find where wellsfargo.com lives, is that really Wells Fargo? But you are now great. You feel like that's really Wells Fargo and that's actually where it lives. And you feel happy as a consumer, but you've just relied on multiple third parties to provide that security for you. And the problem is that there are hundreds, in the case of certificate authorities, there's over 4,000 certificate authorities around the world that can essentially provide certificates and read everybody's data that you're relying on. And so for industry and critical infrastructure, you can't use public certificate authorities like consumers can use. Okay. Removing those from the equation is a requirement basically for any zero trust network or any bridging network. Do not use public security for my network. So that's number one. No internet third parties are required for connectivity. Number two is all connections can be explicitly whitelisted / allow listed. In other words, this is not just a VPN connection where now, let's say on the number two circle, the Clean Connect platform can access everything in the network that's inside the customer facility. These systems need to have the policy of least permission. This is another zero trust phrase, the policy of least permission, which means that the Clean Connect platform can only access the edge AI system. Okay, only access that system, not access the network on which that system resides. Okay, and so a zero trust model uses the policy of least permission, giving very precise allow list connectivity. Okay, so these first two items are shared pretty much by zero trust networks. Okay, the last two, though, are unique to Diode. Okay, because in all other zero trust networks, when you store the capability, for example, for the edge AI to talk to the Clean Connect platform, okay, you're not talking to the Clean Connect platform and the edge AI and giving each other each of those things the information. You're provisioning what's called an access control list that resides in a database. Okay, and so when the edge AI wants to send data to the Clean Connect platform, that bridging network uses that database, that access control list that says, yeah, that's allowed. That access is allow listed and okay. The problem with that is that you are now substituting a public internet third party for a private internet third party. You are now trusting, whether that's Tailscale or Zscaler or whatever, you're trusting that the access control list that they've stored, okay, that they have the keys to, is not compromised. And in fact, that they are correctly updating it whenever you, as a user or the owner of the access control list, you're not really an owner, you're just giving permissions to it, is able to do that. And so what Diode does is said, we want to give the owner, the facility owner or Clean Connect, we want to give you mathematical ownership of that access control list. And you can do that with blockchain. Okay. And so you can have provable data provenance for the unique identities, globally unique identities involved with the system. You can have provable data provenance that this connectivity is allowed connecting to this connectivity, and that only the owner of the system, only the owner of the network perimeter, the network definition, is allowed changing that. And both sides can audit it, as well as any third-party auditing tools. And you can do this in a way that is public, that actually the other people can see it, or you can do it a way that is private, that only the participants in the system can see that. And Diode has both. But that's number one, is that you have provable data provenance and that you are not risking any type of problem in the access control list. Okay. The fourth one is that you can have auditable server and device identity permissions at any level you choose. Okay. So Diode has a public network out there that has these access control lists that can be initiated by an owner, fully mathematically controlled by the owner, can't be subverted by Diode or anyone else on the internet. And Diode has a public network that then it has a provable way that is using these access control lists. But when a facility bridges between the edge AI device into the Clean Connect platform, you're bridging through one of the public servers using this. And critical infrastructure and systems like oil and gas are, for a good reason, traditional in the way that they want to use internet infrastructure. They want to know that not only that I'm not using internet third parties, but also that I explicitly know which IP addresses that my infrastructure is connected to. Okay. Now, with a SaaS system like Tailscale, you can't really know that, right? Because a Tailscale server can go up, go down, and they're going to bring in, and they're not under your control, right? Like that IP address, you can't prove that you know what's on that server. Tailscale or Zscaler is running that. Okay. Diode is a permissionless zero trust network, which means that as Clean Connect or as the facility owner, you can add a node, a zero trust bridging node, to the network that takes advantage of the blockchain network and the blockchain mathematical security. But yet that IP address of that server is your server, right? And it's then managing the bridging between the different entities. And so in this way, you can have full audit logs, fully allow lists the specific IP addresses, and you have the advantage of the SaaS aspect of the security with the self-custody aspect of the communications and where the bits and bytes are actually going. And so we believe that this is the best of all worlds that you can get. And we're very excited to be working with Clean Connect on this.
Very nice. Yeah, I can see as we scale up, this is going to be more and more critical.
Absolutely.
Okay, listen, Hans, I appreciate so much explaining Diode, explaining how it can be used in our specific circumstances. And we continue to build out on this journey of this empirical energy. I think security is such a big thing because, yeah, we've made the case in other episodes about the importance of getting access to those meters and things that are measuring all that critical infrastructure. Absolutely. But everybody has the logical question then, how are you going to secure all that so that it doesn't, people can't get in or get out? And I'm super glad that the blockchain came around and then you figured out how to use that native technology to fully secure these networks.
Absolutely. Yeah, there's part of the challenge that is just increasing complexity for centralized management, right? In that, like, how many ports, how many other third-party servers are out there being used, et cetera. And now we have autonomous AI agents that all of a sudden need access to sensors or machines, right? And now you need to provision the autonomous agents, but they want to provision themselves. And this is a ball of wax that is going to keep getting bigger and more complex without full automation. And when you have the requirement of, let's say, a tier 4 data center managed by third parties, because the security network itself is very complex, you risk hitting a point where the complexity is, you can't deliver the functionality. And so I think that automation that the blockchain offers is an answer to the autonomous edge AI and autonomous AI agents of the future. I think it's going to have to go this way. And that then should allow facility managers to be able to really operate at the policy level, which is really where they want to be operating as long as everything else is automated. But then it also gives you really interesting with respect to Clean Connect's Proof Zero capabilities, right? It gives you really interesting provenance because when you are creating, let's say, MMBTU of clean energy, that initiation, the birth of that MMBTU or anything else that you're attributing to as Clean Connect really needs to have like an audit and an identity that you know exactly where that was born at. And using some of the zero trust and the global unique identities and the auditable connections, you can prove all the way down to the sensor exactly where your data came from, how those points of value were being created. And it allows really full automation and that real-time value delivery for the end customer and for every supplier in the middle as that's implemented.
Excellent. Thanks, Hans, for being a guest here. I know we're going to have you back whenever we're talking about cybersecurity. So thank you so much. Appreciate it.
Awesome. Thanks, Mark. Yep. Okay.
The Empirical Energy Podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and we'll see you on the next episode.